How LEDs obliterated the incandescent bulb empire in 10 years. Picture this. You're standing in a Home Depot in 2008, staring at an entire aisle dedicated to incandescent light bulbs. 60-watt, 100-watt, frosted, clear, floodlights, chandelier bulbs, thousands of glowing filament bulbs that had dominated lighting for 140 years. Now, fast forward to 2018. That same aisle? 90% LED bulbs, with incandescent relegated to a tiny corner section marked specialty lighting. What you just witnessed was one of the most complete industry obliterations in modern history. The LED revolution didn't just disrupt the lighting industry. It completely vaporized a technology that had survived 2 world wars, the Great Depression, and the digital revolution. This is the story of how tiny semiconductors murdered Thomas Edison's greatest invention and turned billions of dollars in manufacturing infrastructure into scrap metal. The incandescent bulb empire in 2008 was a fortress that seemed unshakable. General Electric, Philips, Osram, and Sylvania controlled a global market worth over $40 billion annually. These companies had spent decades perfecting the manufacturing of tungsten filaments, refining glass blowing techniques, and optimizing the inert gas mixtures that made their bulbs last longer. GE alone operated 17 major light bulb factories across North America, employing over 30,000 workers dedicated solely to incandescent production. The supply chain was a marvel of industrial efficiency: tungsten mines in China, glass factories in Pennsylvania, assembly lines in Mexico, and distribution networks that could deliver billions of bulbs to every corner store and hardware shop on the planet. Walmart sold over 2 billion incandescent bulbs per year, and consumers replaced them religiously every 1,000 hours of use, creating a perfect recurring revenue model that had enriched these companies for generations. The technology was so entrenched that the phrase light bulb moment was permanently wired into human consciousness, referring specifically to Edison's glowing filament design. But in the background, a completely different approach to creating light was quietly maturing in semiconductor laboratories around the world. Light-emitting diodes had existed since the 1960s, but they were limited to tiny indicator lights on electronics, those red and green dots on your stereo system. The breakthrough came when researchers figured out how to create blue LEDs in the 1990s, because blue light could be converted to white light using phosphor coatings. Suddenly, you could create broad-spectrum illumination without heating a metal filament to 2,000 degrees Fahrenheit. The physics were revolutionary. Instead of wasting 95% of electricity as heat like incandescent bulbs, LEDs converted nearly all their energy directly into photons. Nichia Corporation in Japan held crucial blue LED patents, but by 2008, Chinese manufacturers like Epistar and Sanan Optoelectronics were ramping up massive production facilities. Cree, an American company, was pushing LED efficiency higher every quarter, breaking its own luminous efficacy records with each new product generation. The market conditions in 2008 created the perfect storm for LED adoption. Energy costs were spiking globally, making the 100-watt electricity consumption of traditional bulbs increasingly painful for consumers and businesses. California's Title 24 energy efficiency standards were tightening, essentially mandating that new commercial buildings use more efficient lighting. The European Union passed regulations phasing out incandescent bulbs entirely by 2012, creating immediate demand for alternatives. Compact fluorescent bulbs had tried to fill this gap, but consumers hated them. They were slow to warm up, contained mercury, and produced harsh, unflattering light. LEDs, meanwhile, were experiencing what engineers call a learning curve acceleration. Every doubling of production volume decreased costs by 30%, while increasing efficiency by 20%. Philips acquired LED manufacturer Lumileds for over $2 billion, recognizing that their century-old incandescent business was facing an extinction event. Even more ominously for traditional manufacturers, LED production required completely different expertise: semiconductor fabrication instead of glass blowing and metalworking. The LED assault began in commercial lighting, where the mathematics were impossible to ignore. A typical office building using 10,000 incandescent bulbs would consume over 1 million watts of electricity continuously. Switching to LEDs dropped that consumption to under 200,000 watts while providing better, more consistent illumination. Walmart announced in 2010 that it would retrofit all store lighting with LEDs, eliminating over 1 billion watts of electricity consumption across its facilities. The company calculated a payback period of under 18 months, after which the energy savings would flow directly to profit margins. Hotel chains like Marriott and Hilton followed with their own massive LED conversion programs. These commercial adoptions created economies of scale that drove LED prices down even faster. By 2012, the price per lumen of LED lighting had dropped below compact fluorescent bulbs, and by 2014, LEDs were cost competitive with incandescent bulbs on initial purchase price while offering massive lifetime savings. Consumer adoption accelerated when major retailers began pushing LEDs aggressively. Home Depot trained its lighting department staff to calculate electricity savings for customers, showing how a $12 LED bulb would save over $100 in electricity costs over its 25-year lifespan, compared to repeatedly buying incandescent replacements. Amazon's algorithm began recommending LED bulbs to anyone purchasing traditional light bulbs, often offering substantial discounts on multi-packs. The psychological barrier of higher upfront costs crumbled when retailers offered instant rebates funded by utility companies desperate to reduce peak electricity demand. Costco started selling LED bulbs in bulk packages, making the per-unit cost so low that price-sensitive consumers couldn't justify buying incandescent anymore. Smart LED bulbs from companies like Philips Hue added features that incandescent bulbs could never match: dimming, color changing, smartphone control, and integration with home automation systems. The incandescent manufacturers found themselves trapped in a technological dead end with no escape route. You cannot make an incandescent bulb significantly more efficient. The laws of physics limit how much light you can extract from a heated tungsten filament. General Electric spent millions trying to develop halogen infusion and other incremental improvements, but these modifications could only boost efficiency by 10 or 15%. Meanwhile, LED manufacturers were doubling their efficiency every 3 years while simultaneously cutting costs in half. Sylvania attempted to acquire LED technology companies, but they discovered that semiconductor manufacturing required completely different factories, supply chains, and engineering expertise. Their existing workforce, optimized for glass and metal fabrication, had no relevant skills for semiconductor production. Osram spun off its traditional lighting division and pivoted toward LED manufacturing, essentially admitting that their core business was obsolete. The writing was on the wall. You could either abandon your existing infrastructure and start over as a semiconductor company, or watch your entire industry vanish. The collapse was swift and merciless. Between 2012 and 2016, incandescent bulb sales in the United States dropped by 78%. GE closed 14 of its 17 light bulb factories, laying off 26,000 workers. Philips sold its lighting division to Chinese investors after concluding that traditional bulb manufacturing had no future. Hardware stores that once dedicated entire sections to different types of incandescent bulbs condensed their selection to a single shelf. The secondary effects rippled through the entire supply chain. Tungsten suppliers saw demand crater, specialized glass manufacturers shut down production lines, and the machinery that had stamped out billions of light bulb bases was sold for scrap metal. Even the language changed. Light bulbs started to sound old-fashioned as consumers began talking about LED fixtures and smart lighting systems. Energy companies had to revise their demand forecasts downward as LED adoption reduced lighting electricity consumption by over 60% nationally. By 2018, the transformation was complete. LEDs captured over 90% of all new lighting installations and over 70% of replacement bulb sales. The remaining incandescent sales were relegated to specialty applications: heat lamps, decorative bulbs for vintage fixtures, and photography equipment. Amazon's best-selling light bulbs were all LEDs, with the top-selling incandescent bulb ranked below the 100th position. The average LED bulb lasted 25 times longer than incandescent, while using 85% less electricity. Consumers who had spent decades budgeting for regular bulb replacements suddenly found themselves buying bulbs so rarely that they forgot which fixtures needed which bulb types. The total addressable market for replacement bulbs shrank by over 60%, as LED longevity eliminated the recurring purchase cycle that had sustained the industry for over a century. The LED revolution represents one of the most complete industrial obliterations in modern history. A technology that had dominated for 140 years was virtually eliminated in a single decade, not by gradual improvement, but by a fundamentally superior approach that made the old technology obsolete overnight. The lesson is brutal but clear. When a new technology offers 10 times better performance at half the cost while requiring completely different manufacturing expertise, incumbent companies don't adapt. They disappear. The billions invested in incandescent manufacturing infrastructure became worthless not because of market forces or competition, but because physics itself had moved on. Edison's glowing filament, one of the most successful inventions in human history, joined the ranks of obsolete technologies like steam engines and film cameras. And unlike those technologies, which faded gradually over decades, the incandescent bulb empire was vaporized in less time than it takes for some LED bulbs to burn out.